Okay, so for the first problem, we're finding out if SO3 is polar. Basically, we first just need to draw the Lewis dot structure. Lewis dot structure is pretty much just making sure all the atoms have octets and that the 24 of the valence electrons are used. So we can see clearly that all 24 are used because there are 12 sets of electrons, except for on sulfur, there's not an octet. There are on oxygen, but sulfur is an allowed octet violator. Next, we need to see if the partial charges all equal 0. We can see all the atoms are happy. So we need to look at the molecular geometry. The molecular geometry will be a trigonal planar because there are 3 bonding domains about the center atom, and all 3 have the same dipole. So identical domains with identical dipoles means there is no net dipole, which basically means that the atom is not polar. Next, we're going to see if OF2 is polar. There are 20 electrons in OF2. So basically the Lewis dot structure is going to be set up like this, and we can see that there are 20 sets of electrons, and there are 4 domains about the center atom. Next, we need to check partial charges. We can see that both the atoms are happy. So the molecular geometry is going to be bent because of these 2 non-bonding sets of electrons. So, since there are 4 domains that are different about the center atoms, the dipoles on the fluorine add, and there is a net dipole that points downward. Therefore, the molecule is polar. Next, we're going to look and see if beryllium chloride is polar. So there's 16 valence electrons that we're working with here. So the Lewis dot is going to be set up like this. And you can see that beryllium doesn't have an octet, but again, it's an allowed octet violator. Next, we're going to look at the partial charges, and you can see that both of the atoms equal out to 0. So on the molecular geometry, it's linear because there are 2 identical domains about the center atom with identical dipoles, meaning there is no net dipole, meaning the molecule is not polar. Next, we're going to look at CCl4. There are 32 electrons, and all of them are being used, and all of the atoms have an octet, so it looks good, and the partial charges all equal out to 0. The molecular geometry is going to be tetrahedral because there are 4 bonding domains about the center atom, each with an identical dipole, meaning that the dipoles cancel out and there's no net dipole. Therefore, the molecule, again, is nonpolar. The last one is ozone, which is a little tricky, but the Lewis structure looks something like this. It's kind of a mix. So the resonance structure is like this because both of these have about 1.5 bonds on them. So it looks hard, but basically we can just look at the molecular geometry and see that it's bent because of this set of non-bonding electrons. Therefore, there are 3 non-equal domains about the center atom. Therefore, the molecule is polar. Basically, polarity is just if there's a net dipole about the molecule.